So the idea was this. If I have this huge selection of data, the quickest way to numerically summarize that data is tell me where the middle is and how spread out the data is. That kind of makes sense. So, for example, a regular average quiz or test grade would be around maybe 74, right? And the standard deviation would be normally around like 13.5 or something. So this tells me where the middle of the data is, and this tells me how far on average all the data points got away from the middle. So for example, can anybody tell me, if this is the situation, what data point is 2 standard deviations above the mean? How big is each standard deviation? 13.5. So how do I figure out what data point is 2 standard deviations up from the mean? Yeah, add 13.5 twice. Does that make sense? Of course. If I know the mean and the standard deviation, here's how we use standard deviation in general. Since it is an average distance from the middle, I use that to walk around my data. Does that make sense? I always call these steps. You don't call them steps when you answer a question or a quiz or a test. But just talking about the idea, this is steps. So can you imagine if I had, would you say, which one of these, let's see if you guys get the general idea, which one of these has a smaller standard deviation? Yeah, definitely this guy, right? The skinniness. The data doesn't get very far away from the middle, does it? Whereas this guy, the data gets farther away from the middle. So if I wanted to step around this data, this guy's standard deviation might be this big. And this guy's would be maybe this big. But if I used this to step around here, I miss basically all the, I miss everything. Holy shit, so I got to step around like this, and then I can see everything. Well, that makes sense. A little bit. So standard deviation is like tick marks on a ruler. And then I can use those to measure how far apart things are. So if I was going to measure how far apart 2 people are in this room, would I use miles? No, I am 0.003 miles away from her. No, that doesn't make any sense. I would use a different scale, right? Standard deviation sets up what scale I want to use in my data. Maybe. Okay, so let's come back to real nuts and bolts. How the hell do we calculate standard deviation? It's nice if I got it. How do I get it? So I think last time we got to the point. Let me take one of our data sets from last time. Here. Where'd it go? Sure. I can't remember if we did this already. Let's say Group C's data points from last time. Well, where'd you go? There you go. Okay. Whoop. And the average was 13. Everything was 13, right? So let me be very specific here. Let me start with this. Let's assume this is a population. This is a population that took this. This is the population of Group C. So then the mean would use what symbol? If I was assuming this was a population, what symbol would I use for the mean? Not X bar, because that's for sample. Population uses Greek letters. Not sigma. The M, yeah, the mu. Yeah, so mu is 13. Okay, become a 3. Stay with me now, stay with me. And last time I got you to the point where we kind of defined spread. And then somebody mentioned the name of standard deviation, so I use that name. But what's the definition of standard deviation? It's the average distance every data point gets from the middle, right? So to find the average anything, I have to get a whole list of those things. So the first thing I want to do then is get a list of the distances from the middle. That only makes sense. If I wanted an average shoe size in here, I have to first get a list of shoe sizes. I want an average distance, so I got to first get a list of distances. Kick ass. So let's see. So this would be -7. Is that cool? 6 minus 13. The negative, what do you think that represents physically? 6 is below the average. I like it. So whoever did this, they scored 7 below the average. That's why it's negative.
So it doesn't necessarily mean it's like negative 2 below.
Say again?
It doesn't necessarily mean that it's like negative 2 below.
Yeah, you can't use the word negative really when you talk about distance. Does that make sense? If you're negative 2 feet away from me, are you inside me? Quaid. No. Anybody get that reference now? But the negative means it's below the mean. How far away from the mean? 7. What's the negative mean? It's below. So what would this be? 8 minus 13? 5, 10 minus 13, 11 minus 13, 13 minus 13, that's always nice. And 15 minus 13, 16 minus 13, 18 minus 13, 20, 13. Now, we talked last time about what this is always going to add up to be. This is always going to add up to be 0, because the mean is the middle of the values. It's going to have equal negatives. Not always mirror image like this. The data is symmetric. I don't know if you guys get, you don't have to understand what I'm saying right now, but it's cool if you do. The data is symmetric, that's why it's a perfect mirror image, but it doesn't even have to be a mirror image. All the negatives will add up to equal all the positives. You're always going to get a freaking 0 here. That sucks. So we talked last time about absolute value would be an option, but it sort of mathematically sucks. So the other way to make something positive, talking about real numbers, of course, is to square them. So what we're going to do as a concession, we're going to find the average squared distance, and then we're going to square root that. Okay, so let's see. What do I get here? 49. You know, I was going to need extra space. That's why I get that guy out of the way. Can you guys see okay over there? Probably not. Well enough? Okay. So let me make sure you guys are with me. What am I about to do? What did I just say we're going to find? We made a concession. We want the average distance from the mean, but we're going to find the average squared distance from the mean. So what do I want to do to find the average? How do I find the average of anything? Add them all up. Divide by how many there are, right? So what do you get when you add up all these square distances? 174. 174? Okay, we'll go with that. I didn't really do it, but sounds good. Anybody else do it? Verification? Yes. Okay. I don't not trust you, but I don't know you. Yeah. What's up?
Trust but verify.
Yeah, exactly. I trust you. Just be careful. So to find the average, what in symbols, what the shit is this? In symbols, what is the 174? What did we just do to these? Yes. Remember what? Add them up. Add them up is what symbol? Capital sigma. The Greek letter looks like E, right? Sigma, sigma, sigma. It's used for sororities and stuff. So the sum of these, and then what am I going to do with those? Of course, what do we say? We want the average square distance. So I'm going to add them up. And then divide by the total. What's the symbol for the total number? Number. N. This, what did I say this was? We assumed that this was, and the reason I use this symbol, we assumed this was a population. So what kind of letter do you think we're going to use for standard deviation here? Greek. And the symbol is lowercase sigma. It looks like a fat R. Let's all take a minute to practice making this. Start at the belly, go around to the head. Start at the belly, go around to the head. Start at the belly, go around to the head. So depending on how I feel, I get skinny ones or fat ones or in the middle. It's not an R. But it looks like an R whose leg he did a lot of leg days. I don't know. Here's a normal R, and here's the one that did big, massive thighs. Something like, oh God. Just don't know the eyes of letters. All right, so what you've got to get over, what you have got to get over is I'm not going to put shit here or here. That doesn't make any sense. Because what would I put here? How many things is this? All of these? There's nothing to put here. But I know what this whole thing is. What is that? What is the whole thing? 174. Yeah. The sum of x minus mu squared. So I got a whole bunch. Look, if you cover the sigma symbol, you see what list you need. We got it. Now if I add them up, that's what it is. I added up those. So wherever I see this, I can replace it with 174. So where do I see this? Right there. So what do I put there? 170 freaking 4. Just keep reminding yourself, the formula is an average distance. I know we squared it, so we got to make that concession. So it's an average square distance. Add up all the square distances divided by the number. That's what you do to get an average. That's what the formula is. So what am I going to put on the bottom? 10. So sigma, so this, by itself, it means we haven't taken a square root yet, but this actually has its own name. This is called the variance. Ooh, you are good, I like you. Okay. So when I see sigma squared, that's the variance. How do I get the standard deviation? What did we say earlier? We have to take a square root, so we undo all this weird squaring that we had to do, right? If this is a number of TVs, this is like squared TV. Right? This is like Picasso TV. You know, TV's already square. Shut up. So what do you get when you take the square root?
4.17.
Go further for me. Go out at least 3 places for these. Say it again.
4.1713.
I like it. Like that? 4.171? And you can go further if you want to. In fact, you guys ready? This sounds, look how slowly I'm talking. That's weird for me, so this must be important. Standard deviation must go out at least 3 places. Just if you round too much, it's going to throw things off. But most of the things we're going to work with in this class will actually go out 4 places. So if you just want to take every frickin' thing to 4 places, you're gold. If you make this 4.17, you will lose points. Because I am even. And more importantly, because if you round too much, it throws everything else off. So this is sort of like my concession. If you go to 3 places, everything's basically good. Okay, maybe. Yes?
How'd you get 10?
Oh, I think that's how many data points are we, right? 1, 2, 3, 4, 5, 7, 8, 9, 10. Yeah. Because how do I always run the average? I add up the things I want to average, and I divide by how many there are, and there were 10 of them. So don't always divide by 10. Holy shit.
Yeah.
Yes?
So sigma by itself doesn't have a value. The 174 is the whole.
No. So this sigma squared is the variance. Sigma is the standard deviation. That's the main dude. Right now, this is sort of like, I'm not done yet. I'm not done yet because I haven't taken a square root yet. But this step actually has its own name because it becomes very important later this semester by itself. But right now, this is sort of like, I'm not done yet. Now I'm done. So this is the number that represents the average distance from the middle to every data point. Okay, maybe. So how would the number for group D? Do you guys still have your sheets? Group D was supposed to be the most spread out. So how would its standard deviation compare to this guy's? Would it be bigger or smaller? What did we say about group D? Was it more or less spread out? Group D was the most spread out. And since this is a measure of how spread out it is, group D sigma should be bigger. Because it's more spread out. This is a measure of how spread out things are. I like it. All right. Yes?
Is there a certain name for this type of table?
No.
Okay.
Sorry. This is just a table to get what we need to do this. It's not really got a name. Yeah. If you take another teacher, they might let you put all the shit in a black box of your calculator and have it spit out a number, and you have no connection to it, and you haven't learned anything, but students feel better because they're like, I don't have to do so much work. Too bad you took me. So sorry for that. I will show you, after we finish this worksheet, I'll show you how to get the calculator to spit it out to us so we can check our work. But don't just write down what buttons you pressed. That ain't your work. Calculator passes the class. You got to take it over again. Calculator has a nice life. You're stuck in college. Doesn't make any sense. Has little calculator babies. All right. So here. So this is a worksheet. On one side, it's completely done. It's a whole example for you to reference. It's got the same work we did and a few extra questions. I want to see if you can figure them out. And on the back is the one I want you to do. Okay. Feel free to work with other people. If you don't trust other people, you don't have to.